Welcome back. So, over the course of this section, what we've done is explored different kinds of data distribution. We've taken raw data, we've organized that into categorical frequency distributions as well as numerical grouped frequency distributions. We then took that organized data that has been processed into the frequency distributions and we created different kinds of data visualizations like histograms and frequency polygons. But now that we have a picture that goes with the numbers, what we want to be able to do is verbally describe these images in case we are presenting our own data and want to sort of point out different trends about what different data sets look like. Okay, so starting right off, the first very common type of distribution that you might encounter is called a bell-shaped distribution. The reason why it's called a bell-shaped distribution is because, as you can imagine, this graph here kind of looks like a bell, okay? And if you were to sort of trace alongside the outline of this graph, you can see kind of a bell-shaped curve. Okay? So with a bell-shaped distribution, sometimes you'll hear them called a normal distribution. There are a few properties that you have to be aware of. Now, the first property is that the highest frequency class is in the center of your data distribution. So when we say highest frequency class, what we mean is that the class represented by the vertical bars that is the tallest and has the highest frequency is right here in the middle, and the rest of the classes sort of taper off at the ends, and you can see kind of like a pile of sand. We have the least frequent classes on the ends of our distribution. Okay, this distribution is symmetric, and as I said, the data sort of tapers off at both the left and right end of the graph. Okay, the ninth type of distribution that we're going to get into is the uniform distribution. Now, this is one of the simplest types of distributions that you might come across, and it has one very important property that describes this, and that's all classes have the same frequency or roughly the same frequency. When you're looking at a graph that is roughly uniformly distributed, what you can tell is that your graph will be pretty flat or close to it. You can draw a straight horizontal line across the top, and all of the classes have the same frequency or roughly the same frequency, and so that's why the height of all of the bars are about the same. The next kind of distribution that you guys might encounter is the right skewed distribution. Okay. Now, I kind of think that when it comes to skewed distributions, students can kind of get confused. So I want to be very clear here. The reason why it's called a right skewed distribution is because the classes with the fewest data values or lower frequencies are on the right side of the graph. So if we take a look at our graph and maybe grab our pen just to annotate, our graph has these modal classes over here, that is the highest frequency classes or the tallest bars on the left side, but on the on the upper end of our distribution, you can see that the frequency of these classes is taking a pretty steep dive. And we have these very shallow or short vertical bars over here on the right side of our graph. Sometimes data scientists and statisticians will say that this distribution has a heavy right tail. And so if you think about a tail and lifting it up, then the right side of this graph, the right side or the right tail of this graph is so heavy that it's being weighed down. Okay? That's not to be confused or to sort of think that the heavy tail means that these are high frequencies and that's what makes them heavy. No, on the contrary, this is a heavy tail because it's very low and hard to lift. In other words, the frequency of these classes on the right is very low. Okay, so the data is more numerous over here on the left side which we would say is the lower end of our distribution. But here on the upper end, on the right side of our graph, we have smaller frequencies, and that's what our heavy tail is. Okay, so that's why this is a right skewed distribution, because we have fewer data points over here on the right side. Okay, now that's going to be in contrast to the left skewed distribution. So if we take a look at this shape of the distribution, we can see that the modal classes, or the classes that have the highest frequency, are over here on the right. And as we move to the left, we have that precipitous decline in frequency. That is over here on the lower end of the distribution, we have a heavy tail, right? So again, it's called left skewed because the heavy tail is over here on the left. Okay. A bimodal distribution is a distribution that has two major peaks. So again, as I said in the previous descriptions of graphs, the modal class is the one that has the highest vertical bar, that is the highest frequency. So if we look at this, this is called bimodal because if we trace alongside the shape of this distribution, we have one modal class here, we have a dip in the center, and then it looks like we have another pretty tall vertical bar there representing a high frequency data class, and then we taper off at the end. And so since we have these two major peaks, that's how we know we're dealing with a bimodal distribution, okay? Now, there's other kinds of distributions that might be multimodal. So you might have a third or fourth peak, in which case you would describe that distribution as multimodal, but bi means two, and we can see we have two modal classes here, or two major peaks. And that will pretty much sum up the major or the common types of distribution shapes that you're going to look at or that you're going to encounter as you go through the different kinds of problems that you're encountering in the homework platform. So hopefully these videos that I provided are going to give you some support as you complete your homework assignments and help you sort of consolidate your understanding of statistics and working with data, both organizing your raw data into visualizations and communicating or describing what those distributions look like.